Well, hello, ladies and gentlemen, and we are in the midst of our discussion on redox. And let us jump in right here. Consider magnesium and the silver cation reacting, forming magnesium cation and silver, right? The oxidation half reaction and the reduction half reaction. Okay, looks like there are some new terms here that we need to discover. So, we are in our chapter on reactions, and we talked about chemical equations, and that's a piece of cake, right? And we talked about our types of reactions. And then we started our discussion on redox, and we said, hey, redox is really an overview of several types, that it can include single replacement and combustion and synthesis and decomp, right? And what did we learn about redox? When we looked at the definition, we said, hey, a redox reaction is a reaction in which electrons are transferred, right? So anytime we have the transfer of electrons, we have redox. Now, how can we identify redox? Well, we use our old friends oxidation numbers, right? If oxidation numbers changed for my atoms, then redox occurs. All right, good. And we said we can have oxidation, and during oxidation, what happens? Well, one of my species loses electrons, and what happens to its oxidation number? The oxidation number for that species increases, and I can have reduction. And what happens during reduction? In reduction, a species gains electrons, and what happens to its oxidation state? Its oxidation state goes down. Reduce, go down, right? Good. And so that's kind of our overview of redox. Now, under redox, we want to talk about half reactions here. So what are half reactions? Well, they're what you kind of think. It is what is a half reaction? It is part of a redox. Oops, it is part of a redox reaction. Part of a redox reaction in which electrons are either lost or gained. Okay, that sounds really brilliant. Sure. Now, we have two types of redox half reactions. We have oxidation half reaction. And what do you suppose is that? That is a part of a redox reaction in which what? Electrons are lost, and then we can have my reduction half reaction. And what is that? That is part of a redox reaction in which electrons are gained. And guess what? What is my whole redox reaction equal to? My whole redox reaction is equal to the oxidation half reaction, the oxidation half reaction plus the reduction half reaction. Okay, so if I look at the oxidation half reaction and add it to the reduction half reaction, what do I get? I get the total redox reaction. All right, that doesn't sound so hard, so let us take a look at this. The oxidation half reaction. Okay, we want to show the species that is oxidizing. So what's the first thing we have to do? How about assigning oxidation numbers? Magnesium is 0. Silver cation is +1. Magnesium cation is +2. Silver element is 0. So what is gaining electron? Excuse me. What is oxidizing? What is losing electrons? Which species has an increase in their oxidation state? And that would be magnesium. Magnesium is going from 0 to Magnesium 2 plus. Okay, now, what does that mean? That means the magnesium lost electrons. Okay, if it lost electrons, what side of the arrow is that going to be on? Well, if they lost, it's going to be over here, meaning it gave up electrons. They freed electrons during the reaction. Now, how many? Well, magnesium over here has a charge of 0. Magnesium over here has a charge of 2 plus. Not 0, 2 plus. So how many electrons must have been freed? And the answer is 2, right? Good. And how do I know that? I mean, I can think about the transfer of electrons, but also notice my charges are balanced. Over here, my charge is 0. Over here, my charge is plus 2. Here I have a negative 1. So how many negative 1s do I need to offset that plus 2? I need 2. There we go. So this would be my oxidation half reaction. And then there should be a reduction half reaction, right? Reduction half reaction. And what must be reducing? Well, my Ag plus is going to Ag. Good. Now, if it is reduction, it is gaining electrons. How many electrons is it gaining? Well, I go from plus 1 here to 0. So it must gain 1 electron. Good. Now, so here are my two half reactions. Now what we have to do is we have to make sure that my electrons equal each other. Why is that? Well, in my total redox, magnesium is losing electrons and silver is gaining electrons. Now notice, every time this occurs, how many electrons are freed? Every time magnesium goes to magnesium 2 plus, 2 electrons are freed. So how many times must this reaction, this half reaction, occur to consume these 2 electrons? Well, every time it occurs, 1 electron is consumed. So that means this needs to happen how many times? 2. Good. So then if I rewrite that, I'd have 2 silver pluses plus 2 electrons yield 2 silvers, right? And just cleaning up our reaction on top, I have magnesium going to magnesium 2 plus 2 electrons. Now, let's sum this all up. I'm going to write everything on the left side of the arrow and everything on the right side of the arrow, and I get 2 silver plus cations plus 2 electrons plus magnesium yields what? 2 silvers plus magnesium 2 plus 2 electrons. Can I simplify? Sure, I've got 2 electrons on both sides, meaning these guys cancel. And so what am I finally left with? 2 Ag plus magnesium yields 2 Ag plus magnesium cation. And I could put in my states, right? And that now is my balanced redox reaction. Cool. All right. You guys give this one a try. Bring me back when you're ready. Well, what did we do? We started off with oxidation states and then tried to decide what is oxidizing, and what is reducing. Well, aluminum is going from 0 to plus 3, so that means my aluminum is oxidizing. How does it get from aluminum to aluminum 3 plus? Well, if it's oxidizing, it is losing, meaning my electrons are on the right side of my yield arrow. How many electrons does it have to lose? It has to lose 3 electrons. Good. So this is my oxidation half reaction. What's going to be my reduction half reaction? Well, what is reducing? My iron 2 is going to iron. And if it's reducing, it's gaining electrons. How many? It's going from 2 plus to 0. That means I have to have 2 electrons. Good. And so that is my reduction half reaction. Now, I need to make my electrons equal. Every time this reaction occurs, 3 electrons are freed up. Every time this one occurs, 2 electrons are consumed. Okay, so I go through this reaction one time, I create 3 electrons. I go through this one time, and so I subtract 2 electrons, and I have 1 electron left over, meaning this must happen again, but I subtract 2 electrons from it, and so now I have a -1, which means this one must happen again, so another 3 minus. So I would gain a +3, so now I'm down to -2, which means this happens again. You guys follow that? Probably not. I did that pretty quickly. How do I figure out how many times each of these occur? Well, we're going to go back to our wonderful least common multiple between my number of electrons. Every time my oxidation half reaction occurs, 3 electrons are released. Good. Every time my reduction half reaction occurs, 2 electrons are consumed. What's my least common multiple between 3 and 2? The answer is 6. So that means 6 electrons. How do I get 6 electrons out of my oxidation half reaction? Well, this must happen 2 times to create 6 electrons. How do I consume 6 electrons from my reduction half reaction? Well, this thing must happen what? 3 times to consume 6 electrons. So here we go. I have 2 aluminums, and to that I'm going to add what? 3 iron 2s plus 6 electrons, and that's going to go to 2 times this, 2 aluminum cations plus 2 times that, 6 electrons plus 3 times that, 3 irons. Good. Now let's reduce. I have 6 electrons here and 6 electrons here. Yoink, yoink, and that better happen every time. If your electrons don't cancel, you've made a problem. You've made a mistake. I have 2 aluminums plus 3 iron 2s, aqueous. And what does that yield? 2 aluminum cations, aqueous, plus 3 irons, solid. And that is my balanced redox. Okay, wunderbar. Let's go further. All right, this one looks kind of scary. I have dichromate plus nitrogen dioxide yields nitrate plus chromium 3. And it's in acidic solution. Write the balanced equation using the half reaction method. Okay. Well, this is one thing we want to add here. We want to come down here and we want to talk about a very powerful tool. And it is called balancing using the half reaction method. Okay, good. Step 1, write equation. Usually this is given. Usually that's given. We can all do that. Number 2, we want to we want to we want to assign my oxidation numbers. Okay, we're going to toggle back and forth with this question and with our steps. So here we have the written equation. That's number 1. Number 2, let's identify oxidation states. Well, oxygen is going to be 2 minus 2. And I have 7 minus 14 minus 2, 12. So each of these is plus 6. So my chromium is plus 6, minus 2 plus 4, minus 2 plus what? Okay, minus 2 times 3 is minus 6. It has to equal minus 1. So it's plus 5. And then chromium is plus 3. Okay, so we have identified, we have assigned our oxidation numbers. Good. Now what do we want to do? Next, we want to identify what is oxidizing and what is reducing. We want to ID the oxidizing and reducing species. Okay, good. Here we go. What is oxidizing? Well, chromium is going from plus 6 to plus 3. That means its number is going down, which means it is what? Chromium is reducing. Oxygen is going from -2 to -2. Okay, nitrogen is going from +4 to +5, meaning it is doing what? It is increasing. That means it is oxidizing. Okay, so we've determined what is oxidizing and what is reducing. Okay, let's go back to our notes. Next, what do we want to do? We want to write the oxidation half reaction. Okay, and what we mean by that is we want to write the species involved, the things involved. What atoms are involved in the oxidation, okay? So what is oxidizing nitrogen? So we want to start up here, and we're going to write all of our NO2. So I'm going to take NO2, and it's going to go to what? Where's my nitrogen over here? So over here, NO3 minus. There we go. Now what? Now we're going to have a whole list of things we have to do with this. So we write that. Now we want to balance atoms except hydrogen and oxygen. Okay. What do they mean by that? Well, I have one nitrogen here and I have one nitrogen there. Are they balanced? Yes. If they weren't balanced, what would I have to do? I'd have to change my coefficients, right? But in this case, I have one nitrogen and one nitrogen. Everything is fine. Good. Next step. Balance atoms. Now what do I want to do? I want to balance oxygen using, let's get it more appropriate, by adding waters, H2Os. We want to add H2Os to balance the oxygens. That sounds strange. Yes, it does, but we're going to do it. How many oxygens do I have here? I have 2 oxygens. How many oxygens do I have there? 3. So then I want to add water to which side? Well, which side has fewer oxygens? Well, this side. So I want to add a water. And how many? Well, H2O. There's 1 oxygen. Okay, now I have what? 2 and 1. That's 3 and 3. Okay, now that is balanced. I have balance in my oxygens, but it seems like now I have another problem. Yes, you do. Why? Because I need to balance something else. And what is it that I need to balance? I want to balance hydrogens by adding H pluses. I want to add my hydrogen cations to balance my hydrogens. Okay, how many hydrogens do I have here? I have 2. How many over here? 0. That means I need to add 2 hydrogen cations. All right, cool. And then one more thing we have to do here, and what is that? We need to balance charge. We're going to balance charge, and how am I going to balance charge? By adding electrons. Okay. What's my total charge on this side? Well, when I mean charge, I mean real charge. What's written up here? Well, here's a 0 and here's a 0. So that means my charge on my reactant side is 0. What's my charge over here? Well, I have 1 minus 1 and I have a plus 1, but how many of those plus 1s do I have? Well, I have 2. So I have plus 2. So I take plus 2 and add minus 1 to that, and I get plus 1. Okay, so that means I have 0 on one side and plus 1 on the other. How do I make those equal when I can only add electrons? Well, electrons are what? Negative 1s. So which side am I going to add an electron to? I'm going to add an electron right here, because now that'll make that negative 1 plus, that positive 1 plus a negative 1, 0. So my charge on both sides is now 0. Cool. All right. Easy. That's not hard. We just have to follow the steps. That's correct. It's a little bit monotonous, maybe you might say, but it's not hard. It's meticulous is probably the word I'm looking for. One must be a little meticulous. We want to write the reduction half reaction and then repeat A through D, okay, in above here. All right, I can do that. What's my reduction half reaction? Well, I've got what is reducing my chromium. So that means I'm going to start off with my dichromate, Cr2O7, 2 minus, and it's going to go to what? It's going to go to Cr3 plus. Good. What's the first thing we want to do? We want to balance atoms. Well, we want to balance atoms excluding oxygen and hydrogen, right? Well, how many chromiums do I have there? I have 2. How many do I have here? 1. So what do I have to do? I have to put a coefficient in front of my chromiums. Good. Now what? Balance oxygens. I have 7 oxygens here, so that means I need to add 7 waters here. Good. Now my chromiums and oxygens are balanced, but I have what? I have 14 hydrogens here, which means I need to add what? 14 hydrogen cations there. And finally, I need to balance charge. What's my charge on the left? I have a -2 plus 14 H plus, and that looks to me like what? Plus 12, correct? 12 plus. What do I have over here? Well, I have a plus 3 times 2, so I have a plus 6. So how do I go from a plus 12 to a plus 6? I have to add what? 6 electrons. So we're going to add 6 electrons. All right. So good. I have both my half reactions written. Now what? All right. Next step. 6. We want to make the number of electrons the same in each half reaction by multiplying, right? Multiplying half reactions as needed, right? Like we did before, we want to find the least common multiple and then multiply the half reactions and go from there. So what's my least common multiple? I have 1 electron here and I have 6 electrons here. So what's my least common multiple? 6. So what do I need to do? I need to multiply this whole half reaction by 6. What about the bottom half reaction? Well, it's already at 6, so I don't. So let me rewrite this reaction now. I have what? 6 NO2 plus 6 H2O yields what? 6 NO3 minus plus 6 times 2 is 12 H plus 6 electrons. And I think you guys know what we're going to do now, don't you? Sure, we did this before in our half reaction stuff. 7. Combine half reactions. That means I'm going to put everything on one side of the arrow and everything on the other side of the arrow, right? I'm going to take all the stuff that are my reactants and put it on one side, and all the stuff that are products and put it on the other. So what do I have? I have 6 electrons plus dichromate, Cr2O7, 2 minus, 2 minus, plus 14 electrons, no, 14 hydrogen cations, sorry, plus 6 NO2s, plus 6 waters. And all that equals what? 2 times 2 chromium 3s, plus 7 waters, plus 6 nitrates, plus 12 hydrogen cations, plus 6 electrons. Okay, nothing so hard yet. Now what? We want to reduce, simplify. Simplify. Okay, I can simplify. Here we go. Simplification in process. I have 6 electrons and 6 electrons. What happened to those guys? They cancel each other out. I have 1 dichromate, so let's write that down. Cr2O7, 2 minus. Do we have any dichromates over here? No. I have 14 H pluses here, but I have what? 12 here. So what's the net? Well, 14 minus 12 equals what? I have 2 H pluses remaining on this side. Good. I have 6 NO2s, and then I have what? I have 6 waters here, but I have 7 waters there. That means this guy goes, and I have 1 water on this side, right? plus what? My 2 chromium 3s plus my 6 nitrates, and everything else is gone. Okay, last thing. What do you suppose we should do last? 9. Check atoms and charge. I'm going to make sure my atoms balance and my charge balances. Here we go. Okay, chromiums. How many do I have on the left side? I have 2. How many on the right side? 2. How about oxygens? I have 7 here and 19, right? 6 times 2 is 12 and 7 is 19. Over on my right side, I have 1 and 3 times 6 is 18. I have 19. Good. How about hydrogens? I have 2 on my left side, 2 on my right side. How about my nitrogens? I have 6 nitrogens here, and I have 6 nitrogens there, and charge. What do I have? I have minus 2 here, but I have 2 times plus there, so that is plus 2, and so my charge over here is 0. What's my charge on my left side? I have 2 times 3 plus, so that's plus 6. 6 times minus 1, 0. Woohoo! Woohoo! Wow! Holy cow! Yes, holy cow, that is our answer. Now, is that difficult? No. Does one need to follow the steps? Absolutely. You must follow all the steps. You must be meticulous. Here you go. Give this one a try. Bring me back when you're ready. Let's go. Let's first do what? We have the equation written out. Now let's assign oxidation states. That's a 2 minus, and this 4, 8, and a minus, so that means that must be plus 7. This is a minus 1, plus 2, and 0. All right, so my manganese is going from plus 7 to plus 2. That means it's going down. That is reducing. And my bromine is going from minus 1 to 0. It's increasing, so that is oxidizing. Okay, so let us go here. I start out with Br minus. It's going to Br2. First thing we want to do is balance my atoms except for oxygen and hydrogen. So that means I need to do what? Put a 2 there. Now I need to balance my oxygens. Hey, my oxygens are balanced. There's 0 on both sides. I need to balance my hydrogens. 0 on both sides. Now I need to balance charge. Here I have 2 times minus 1, which is negative 2. So that means I need to get a negative 2 on this side. How? I'm going to add 2 electrons. There we go. So now my oxidation half reaction is finished. Next, let's go to the reduction half reaction. I have MnO4 permanganate, and it's going to go to manganese 2 plus, right? Manganese 2. Balance manganeses. Well, they're both balanced, 1 on each side. Balance oxygens by adding water. So I have 4 oxygens on my left. That means I need 4 waters on my right. Balance hydrogens. Okay, I've got 4, 8. I need 8 H pluses. Balance charge. Over here I have 8 times 1, so I have a plus 7 here. Over here I have a plus 2, which means what? I have to have a plus 5. By the way, notice, folks, your electrons in your 2 half reactions must be on opposite sides. If not, you made a mistake. Good. Now what do we want to do? We need to get a least common multiple for our electrons. Here's 5 and 2. 5 and 2, my least common multiple is 10. So I need to take this equation and multiply it by 5. And I need to take this equation and multiply it by 2. Let's do that. So let's take the top one. 5 times 2 is, I have 10 Br minuses yields 5 Br2s plus 10 electrons. And my next one is what? 10 electrons plus 16 H plus 2 permanganates yield 2 manganese 2s plus 8 waters, right? Now, let us combine and simplify. So I have 10 electrons plus 16 H plus 2 permanganates oops, sorry about that, minus, plus 10 bromides yield 5 bromines plus 10 electrons plus 2 manganeses plus 8 waters. Good. Now let's simplify. 10 electrons here, 10 electrons here. Yoink. I have 16. This is the only place I have H plus. Hey, I think we're simplified. There's no waters on the left side. There's waters on the right side. Okay, so what do we need to do? Check. H. How many H's on the left? 16. How many H's on the right? 8 times 2, 16. How many MNs on the left? Well, I have 2 times 2. Mn2, good. How many oxygens? 2 times 4 is 8. It looks like 8. How many over here? 8 times 1 is 8. Cool, everything's working out. Can you believe this? Let's hold our fingers crossed. 10 bromines. 5 times 2 is 10 bromines. Now charge. Please, 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 please. Charge. Okay, you have 16 plus here. And 2 times plus a negative 2 plus 10 times a negative 1. So what is that? Negative 12. That looks like a plus 4. Looks like I have a plus 4 on my left. What about on my right? Well, 5 times 0 is 0. Hey! We're winners. We are the champions, my friends. Woohoo! There we go. Everybody, give yourself a pat on the back. That is how we balance redox. You must follow the steps, and it is exhaustive. See you.